Hello and welcome to this channel. My name is Dick van Oeveren, and in this fifth MPLS video I will take you to Vpls, a demonstration on how to configure Vpls on Comware devices. So Vpls is an MPLS service that allows you to establish point to multi-point layer 2 services. So for configuring Vpls we have three different options. We can create a static Vpls, Martini Vpls and a Kompella VPLS, very much like we have done in the previous video configuring the layer 2 VPNs. So again, the main differences are related to the signaling protocol. With static VPLS we use a static labeling configuration, and with Martini VPLS we use LDP as signaling protocol, and for the Kompella VPLS we use MP-BGP as signaling protocol. Similar as with the layer 2 VPN setup, we have a couple of options to configure the edge connectivity. So here are the diagrams. So the first one is pretty straightforward and allows you to pass untagged traffic across the VPLS. In the second scenario, what we have here is we are allowing tagged traffic to pass, and in the third scenario we are performing VLAN translation. You can see that on side 1 we have Vlan 10 as tagged Vlan configured, and on side 2 we have Vlan 20 configured on the CE, and on side 3 we have Vlan 30 configured as tagged port on the CE. I will show you how to set up a Martini VPLS and a Kompella VPLS. For the Martini VPLS I will only show you the untagged scenario, and for the Kompella VPLS I will show you how to configure the tagged and VLAN translation scenarios. So both tagged and VLAN translation configs are exactly the same, whether you configure it for Martini or Kompella. Let's start with the Martini VPLS setup. For the label edge routers we have a basic setup with MPLS layer 2 VPN and LDP enabled, and let me show you the peering relationships. So display BGP peer IPv4. You can see that the peering is established with the other PEs, with the other label edge routers, and let me also show you that LDP is working. MPLS LDP peer. So these are the peer relationship with the label switch routers, with the P devices. And let me also show you on the other label edge routers. Okay. Okay, so the setup of the Martini VPLS service is pretty straightforward. The first step is the creation of a virtual switch instance on the label edge routers. So let me create that one. VSI custom array, for example. I set the pseudo-wire signaling to LDP. And what I have to do now is I have to create the peering relationships with the other label edge routers. So peer 1114, and I'm using pseudo-wire ID 500, for example. And I have to do the same thing for the other label edge router. Okay. So that's it for label edge router 1, and we have to do the same on the other label edge routers. Previous signaling, which will be LDP. Pseudo-wire RD 500, and we have to create one for 5. Signaling LDP. $500, and another one for label edge router on site 2. And then the second step is to assign a VSI, the virtual switch instance, to a physical interface that points to the customer edge. So on all the label edge routers I have connected interface gig 103 to the CE, so let me get that working. Interface gig 103, create the service instance, setting the encapsulation type to default, and then I'm performing the XConnect VSI customer A. And that's it for the label edge router. And let me just configure the other ones as well. 03, service instance 1, encapsulation default, and XConnect VSI customer A. And on the third one, service instance 1, encapsulation default, and then XConnect VSI customer A. And that concludes the configuration. Let's see whether the pseudo wires are up and running. So let's take label edge router 1. I do display layer 2 VPN pseudo wire. I can do verbose, for example. You can see that for the label edge router 1114 and 1115, the pseudo wire state is up. I can also show you the VSI status. So display A2 VPN VSI, and you can see that for customer A the VSI is also up. And of course, let me show you that I can reach the other switches from one of the CEs. So let me show you the IP addresses. So I'm on CE2 now, and that one has 172.16.10.2. The CE on site 1 has 10.1, and the CE on site 3 has IP address 10.3. So 16.10.1. You can see that one is reachable, and let me try the 3, and 3 is also reachable. Now this was a pretty simple setup. Let's check out how a Kompella VPLS is configured. This is a little bit more work, but still pretty straightforward. For the Kompella VPLS, we are adding an additional step, and that is configuring a layer 2 VPN address family in BGP. So we only have to enable the peering with the other label edge routers. So for label edge router 1, PE1, this would be the following. Let me go to the BGP instance and create a address family for layer 2 VPN. And then what we have to do is we have to enable the remote peers 1.1.1.4, so that's the other label edge router, one of the other label edge routers, and 5. Okay, we have to do the same on the other label edge routers. And create the address family layer 2 VPN and enable the peers. And on this one, okay. So let's see if the peering is established. So display BGP peer layer 2 VPN. You can see that the peering is established. So what we can do now is we can go to the second step, and that is configuring the virtual switch instance for BGP. This looks very similar to configuring the XConnect group actually for a layer 2 VPN. But let me show you, let me guide you through the config. So VSI customer A, and we set the auto discovery to BGP, and we are using a route distinguisher and setting the VPN target, and we set the signaling protocol to BGP, and we create a site. Site 1, range 10, default offset 0. And we do the same on the other label edge routers. VSI, customer A, and we set auto signaling, auto discovery to BGP. Set a route distinguisher, a VPN target, set the signaling protocol to BGP, and create a site. So this will be site 2, range 10, default offset 0. And then finally on the third label edge router, auto discovery BGP, set a route distinguisher 10.1 and a VPN target 10.1. Set the signaling protocol to BGP and create a site. 3 range 10 default offset range 10 default offset 0. And then the final step is assigning the VSI to the physical interface like we have done with the Martini VPLS. So let's go to the interface, create the service instance, set the encapsulation, and then do the XConnect VSI customer A. And let's do this on the other label edge routers as well. Service instance 1, encapsulation default, XConnect VSI customer A. And that's it. So let me show you whether the pseudowires are established and also the VSIs. So we can do this with the display layer 2 VPN pseudowire. Let's do verbose again. So we have remote site 2, remote site 3, and you can see that they're all up with their in and out labels. And also let me check the display layer 2 VPN BGP verbose. You can see the VSIs here. Customer A is up using BGP Vpls encapsulation signaling. There you go. And we have remote site 3 as well. And there's another one, display layer 2 VPN BGP VSI customer A. You can see here the labels and route distinguishers, and the state is set to up. So again, let me show you that I can reach the other CEs. I don't have to change anything to the VLAN configuration because it's all untagged. Display IP interface brief. Let me show you. So that one's got 10.2. I should be able to ping to 10.1. And I should be able to ping to 10.3, which is CE3. Now for the second scenario, allowing traffic that is tagged to pass. For this I only have to make a minor change to the service instance. I have to set the encapsulation type to tagged. Of course this has to be done on all the label edge routers. Let me show you. So undo XConnect VSI, undo encapsulation. And what we have to do is set the encapsulation type to service VLAN, and we have to define the VLAN that we are terminating. So in this situation, this is a VLAN 10. And then we are going to create the XConnect again. Okay, so we have to do that on all the other label edge routers as well. Go to VSI, set the encapsulation to SVIT 10. And do an XConnect to VSI customer A, and then on the third one fit 10 and X-connect VSI customer A. In addition, we have to make some changes to the CEs because we're now on tagged VLANs. So this change is straightforward. I have to create a VLAN, assign an IP address to that VLAN, and then assign that VLAN as a tagged member to the CE port that is connecting to the label edge routers. I will show you how this is done on one of the CEs, and I will skip showing you the configuration of the other CEs for the sake of time. So I've got CE2 here. What I first have to do is I have to undo interface VLAN 1 because I've got the IP address configured on that one, and then I'm creating VLAN 10, interface VLAN 10, and assigning the IP address 172.16.10.ce2, so that's address 224. And then in addition, I'm going to the uplink interface, set the port link type to trunk, and assign VLAN 10 to the trunk port. You can see the interface is up now. Okay, so also let me show you the status of the layer 2 VPNs. There's some other nice commands that you can use to show what's happening. So let me show you the layer 2 VPN service instance verbose command. What you can see here is that we are using a service VLAN encapsulation. You can see that the state is up. Statistics are disabled, so what I can do is I can actually enable statistics, and this will allow you to view some of the incoming and outgoing traffic. So if I would do display layer 2 VPN service instance verbose again, you see some additional information here. Okay, so let's put it to the test again. Let's configure the other CEs. So let me see if I can ping the other side 16.10.1 for example, and I can do that, and let me see if I can ping CE3. Okay, so this is all working for the tagged VLANs. And then for the third scenario, we're performing VLAN translation. Again, only a minor change in the service instance. So what we have to do is we have to change the service VLAN IDs, and then obviously on the CEs we have to make some changes to the VLAN configuration as well. So for site 1 we will be configuring VLAN 2, for site 2 it will be VLAN 20, and for site 3 this will be VLAN 30. So let me guide you through the configuration of the label edge routers. So we don't have to make any changes to label edge router 1 because that stays on VLAN 10. So we only have to change the label edge router 2 and label edge router 3. Let's undo the X-connect again, undo encapsulation, and then set the encapsulation type to svit and then 20. And then do the X-connect again, VSI customer A. For label edge router 3, svit 30 for VLAN 30, and do X-connect VSI customer A. And then of course on the CEs we have to change the VLANs again to, well, actually only the CE2 and CE3, so we don't have to touch CE1. And then for the sake of time I will only show you the configuration of CE2. So what I'm going to do is undo VLAN 10, and I'm going to create VLAN 20. We're on CE2 here. 20, assign IP address 16.10.2, and then go to interface gig 1/0/3. Let's display this. You can see that VLAN 10 is still assigned, so let's unassign that one. Do port trunk permit VLAN 10, port trunk permit VLAN 20. Okay. So that Vlan is up and running again. And let me also change CE3. Before we do the communication test between the CEs, let me just show you the status of the layer 2 VPNs again. So display layer 2 VPN, let's take a service instance and do a verbose. You can see that we're having service VLAN 10 here. Let me just take PE2 here, do the same. 2 VPN service instance verbose. And I'm using service VLAN 20 here, and for label edge router 3 I'm using service VLAN 30. So, and finally the communication test, we're on CE2, so let's ping 172.16.10.1, which is CE1. That one's working. And let's try 3 as well, which is CE3, and that one's working as well. So this concludes the MPLS VPLS demonstration video. Keep on the watch for more MPLS demos. If you have any comments or feedback, please let us know, and thanks for watching.